Hello, class. I'm here to talk about the third distribution under chapter 4. The third distribution is called the geometric distribution. The best way to remember is think of a binomial distribution, but they call it negative uh, binomial distribution because in the geometric, the easiest way for you to remember is that you're calculating the number of failures before you succeed, which is the other way around for binomial. For example, if I ask you to test at most five five trials. So you're gonna do failure, failure, you're gonna test failure, probability of failure, probability of failure, probability of failure, and then once you reach success, you stop. Okay, so that's why it's called negative. You're looking really probability of having X failure before you succeed. You're always gonna use this is the formula right here for the negative geometric distribution, which I said if you can go ahead and read all this information here, but instead of having to go through all this, I rather you just do the formula and you're gonna see how much easier it is. You can go ahead and read the characteristics of the geometric distribution over here. Let's go ahead and try a problem and you're gonna see how I can use that formula. So let's see the first problem for geometric. We already at Poisson distribution. That would be binomial and geometric. I guess I passed it twice and I didn't see it. Here we go. Let's look at problem 74. Okay, so you know what? Let me go ahead and even copy over here like I did it before. So we're just gonna assign this for your homework. So you're gonna have to solve problem 74. Okay. So let me make this a little bigger over here. Here we go. Okay, these are your formulas. Remember, when you have a zero or actually it's supposed to say false, that means if I put it here, I think it's gonna consider, yeah. So I have to remove the equals, which means you're looking for a value, an exact value. When you have uh, true, those are cumulative values that we're going to be using here when for problems that ask for at most, okay? Or if you're working with at least and then you subtract one from the at most. So let's read the problem. Oh, and then you're thinking here, well, how am I supposed to know this is supposed to be a geometric problem? Well, if you look here, a consumer looking to buy used red Miata car will call dealerships until she finds one that carries. So pretty much you're gonna fail all the way until you find a success. And it gives you a percentage and a probability. So you're definitely dealing with the geometric distribution. So let's start the problem, which you're gonna be asked to answer them in words. We're going to define x, which you're going to need over here. So x is going to be, uh, let's just copy it from here. Oh, interesting. Oh, it's dividing too. So the number of dealerships she must call to find a used red Miata. Okay. So the values that it may take home, well, she needs to call until she finds one. So really, she can call one. X can be one, two, three, four, infinite. So we don't have a maximum amount. Now let's give or state the distribution. So we're talking about geometric. So we're going to do X is this denotes is a geometric distribution, and really all you need is the probability that is giving to you on the problem, 28%. Okay, now on average, I mean, how many dealerships would expect her to call until she finds one? On average, if you go back to your book, The formula for the mean for the random variable, it's the average, it's 1 divided by the probability. So in this case over here, it's going to be equals 1 divided by the 0.28. So that's 3.6, but of course we cannot call 3.6 dealerships, so let's put 4. So she has to call 4 until she find one in average. Now find the probability that she must call at most 4 dealerships, at most, no more than 4. Well, remember, if we're looking for the most, we're going to be using this formula over here. But there's another thing too. So you're looking on number 4 to succeed, right? And we're looking at the failures first, succeed and stop. So we're looking for a failure, we're looking for a failure, we're looking for a failure, and then we succeed and stop. So really, you're just using 3 values right here. So let's go ahead and put the equal signs to make a formula in Excel. So my geometric distribution, which is called the negative binomial distribution formula. So we're looking for 3 failures, right? And then right here, find the probability that must go at most 4. On the R, right here, you're always going to be using 1. The R is going to denote success. So you want 100% success. P is going to be the probability that is given to you right here on the problem, and it's telling you to use true for at most, right? Oh, you already did. So, okay. And then true. So the probability, it's going to be 73%. Okay, now find the probability that she must call 3 or 4. She must call 3 or 4. So think as this. She must call 3 to succeed, So she's going to fail. She's going to fail, and then she's going to stop, right? And then for 4, she's going to fail, right? Fail, fail, and then stop because she succeeded. So really, you're doing the addition of calling 2 plus calling 3 because she's going to succeed in the last one. And so let's go ahead and let's use this formula right here. We don't want a cumulative, okay? So we're going to call 2. We want 100% success. We have a 0.28 probability, and I don't want a cumulative. And now I want to add, keep going, again, a negative binomial distribution or geometric distribution for 3. Now I'm looking at this one right here. And then I want a 100% success. And I have a 0.28 probability of succeeding. And it's a false. I don't want a cumulative value. So let's go ahead and do enter. So the probability that she is going to find that she's going to have to call 3 or 4 dealerships is about 24.9 or 25%. And then you're going to be done with this problem as well. So just to show you that once you had the formulas, and you learn how to plug the numbers. The most challenging here is to read the problem and make sure you don't confuse the definitions. And you would be done with this problem 74 in the geometric distribution.